Cool. Hello, everyone. Thank you for joining our public event. We have the Propeller team here today. They focus on pretty much making the crypto supply chain fair for all of us. They're going to go into a deep dive and expose how to get hooks to be able to connect to all the fragmented liquidity across the blockchain. Please, Marcus, take it away.
Thanks a lot, Rafael. Thanks for having us. Yeah, super excited for this. So we want to talk about Orderflow and maybe give you a bit of background on us. We've been deeply involved with winning flow, first for ourselves and now for everybody else, for a good 3 years now. We've been a Cowsop solver. We've been running also a Uniso X filler and a 1inch Fusion filler at some point. And we've talked to pretty much all of the auction designs and routers and even wallets and frontends who are in control of the flow and are looking to find the best prices for their users. And for a good 2 years now, pretty much 2 years now, we've been developing tooling for solvers so that they can win more flow, and been deeply involved with both the DEXs who want to win flow and the solvers who want to use DEXs to win flow in auctions. That's a bit of the background. And today we have Tanai, who's leading growth on our side, and Alan, our CTO. And I just want to share the basics, but if you have questions, I'm at any point willing to stop and dive deeper into the details of what does it mean to win flow and why should you care. So yeah, please feel free to raise a hand or interrupt at any point. We have some time today, and I'd be more than happy to go into the details. But the slides are focusing on the basics, and then we can later, with the questions, go into more details. So let's get started. The title of the talk is How to Win Order Flow, and it's not for no reason. I think that pretty much everyone in the trade supply chain is mainly and firstly concerned with how to win order flow. And this is, for DEXs, no different. Flow means winning, right? Why does it mean winning? Because flow is ultimately what generates fees. Fees are what generate revenue, and revenue are what make a project valuable. But fees are also what generate yield and what generate TVL. So TVL, meaning liquidity providers depositing liquidity into your DEX, if your DEX does depend on liquidity, will only happen to the extent that you have yield and that you offer yield to those liquidity providers. Those are powered by fees, and that is directly dependent on flow. TVL, as you most likely know, is next to flow the number one success metric that many explorers are measuring for how successful a DEX is. I think flow is like volume is a more direct measure because it really shows how much your DEX is being used. Nevertheless, it's not a coincidence that TVL is also a measure, because TVL supports flow, as we'll see in a moment. So this is why I think flow is the number one thing you should be caring about, and that you should be optimizing for in your design and also in your marketing strategy. Now, the real question though, is how do we get flow, and what are all the options? And I think that can be quite confusing when you're entering the market, especially when you haven't been a market participant before. You haven't designed a router, or you haven't been part of an auction. You're literally coming into this game from a DEX design perspective, and you haven't been involved with the algorithms that route flow before. So it can be quite confusing. What is it that brings flow? And I think there's a couple of, I put a couple of options on the slide here. Many think that to get flow, you have to integrate yourself. Like, you have to go and talk to Consensus, talk to Zerion, talk to all the front ends, and get yourself integrated directly in the front ends, and that's how you're going to get flow. So you need to do BD before you launch to get this flow, maybe. Another one is UX. If you have a better UX, you're going to get more users, you're going to get more flow. You need to have a really strong front end for your hook in order to get the flow that you want, maybe. Or you need to have a strong brand. You need to associate yourself with the right brands. You need to have the right investors. You need to have the right marketing strategy, and then you will have enough attention, and then you will get the flow. or you need to bribe people with points or where you need to have a strong airdrop or tease a strong airdrop in order to get people to want to trade on your hook, and then that will start the flywheel so that you have flow. Or there's referral programs like the Hyperliquid builder program, where if you give the right referrals and the right incentive structures, maybe you will be able to start a flywheel and you would get the flow. And these are all legitimate options, but I think they are all secondary to one single observation. And that is, if you look at order flow, and luckily today, it is easier than ever to look at where order flow is coming from. You can go to orderflow.art. I'm pretty sure you've all seen this chart. And there it's pretty obvious that most of the flow today is coming from one single source. So you can see everything up until the middle of the chart here, which is much more than half the flow, because it is for UX equity reasons that it takes only the half of the screen. All of these are routers. These are all, and the biggest chunk of all of these routers is CowSwap. This is also a router. This is also a router. This is a front end. You see that actual front ends, of which Uniswap is the largest, are taking the smaller share. And I don't have the historical chart now, but you can go to the website and go through front ends. And on the historical charts, you'll also see that this has been a trend over time, that routers are increasingly getting more of the flow and are already by far the majority. And front ends are less and less and less important. There are, in fact, now many DEXs. For example, one is SolFi on Solana, that have no front end. They don't even have a website. They only integrate with routers. And that's how they get the majority of the flow. And they're able to win a large chunk, or the largest chunk of the market in some cases, by only having integration with routers and nothing else. No one even knew about the project or who it was built by for quite a while. So the answer is flow comes from routers. All other answers are secondary to being and getting flow from routers. Now, okay, if that is truly the case, and I hope I made a good argument for why, how then do you get flow from routers? And luckily, this is also simple. Routers care about one thing. They care about price. They are rational routing algorithms that simply look for the best price in order for them to win the auctions that they are competing in, meaning giving the best price to the user. So they are very simple optimization algorithms. They care about price. That's the only thing they care about. And that price being atomically available. Alan will get to that later. Now, okay, how do you get the best price then? One big chunk, and we're not going to talk about this today, I think that is mainly what you're probably spending most of your time on, is the mechanism of how your AMM works. But secondary to that, price, well, is dependent on the TVL. We'll get to that in a moment. So we already established price is what gets you flow, because price is what gets you the routers, and routers is what gets you flow. So the simple answer to how to get the best order flow is just have the best price. Now, of course, that's not very satisfying, because how the hell do we get the best price? One thing to notice is that price is in a reflexive relationship with flow. And this is really what makes AMM growth interesting and complex. Having flow improves your price for almost all DEXs, because flow brings fees you can use to pay LPs to deposit TVL into your protocol, into your hook and AMM design. And almost all AMM designs will improve their price and their depth if they have higher TVL. So this is true for almost all AMMs, that flow begets flow, because flow brings fees, brings yield, brings TVL, improves depth and price, which gets you more flow from routers. You see, I already also put in the design, which is a fixed input, which is the quality of the design of your hook. This is not the interesting part for this presentation. Interesting is we have a reflexive relationship, which makes this a very delicate situation, because that means that if you have little flow, you're going to continue to have little flow. And to grow your flow, you need to win against everyone else who's also playing the same reflexive game. Now, the way that almost all dexes play this game is that they push themselves to a high level of flow through some sort of subsidized incentive. You see that today. I think there's a $20 million grant going on right now, subsidies from the Uni Foundation to bring flow to Uniswap before and to bring flow to Unichain. This is not a coincidence. It is the most effective way to bootstrap yourself into the situation where you have flow and then you have good prices. And you see that in order to have high price quality, you need to lift yourself through subsidies to a point where you have enough TVL to support good prices continuously. And then you can have the unsubsidized curve, sorry, this wrongly labeled here, the unsubsidized curve, which is the growing curve, stabilize, and then you can stop having subsidies. So you first need to bring yourself to high price quality. That begets you flow, and then you can remove the subsidy. And really, the question is, how do you remove the area under the curve here? Because every little bit under the curve is high cost. And depending on how deep your budgets are, you might not last very long subsidizing your price quality. Turns out, as we said earlier, the most important source for flow is routers. And if you have the price quality, the only thing holding you back from getting flow from routers is them actually seeing you. And now this is not as trivial as it sounds. The hardest task for routers today, and the one that they do the hardest in prioritizing, is integrating new DEXs, hooks, liquidity sources, market makers, any sort of source of liquidity. This is the hardest part for routers. And this is where they are the harshest in prioritizing. And the longer it takes you to get those integrations, the longer you need to subsidize, and the less likely you will survive and win against competition. Any integration, and I want to be clear about this, any integration that you miss is a subsidy that you have to pay in order to maintain the same price quality as another AMM who has similar design but more integrations. You need to keep paying in order to stay in the game. If you don't, your flow will fall, and so will your TVL, and you will not be able to compete anymore. So really, if this is true, the game is to get as many integrations as possible in the shortest amount of possible time. If you do that, then you can reach high flow, or the flow that your mechanism deserves, with little subsidies. So the real issue, though, is that there are increasingly number of hooks out there, and there are increasing number of routers. And every router needs to integrate with every hook one-to-one, or with every DEX one-to-one, which is also why it is so hard to get routers to prioritize your integrations. It's also an unmaintainable situation where routers today, the reality is, only integrate the main largest DEXs and hooks that already have a lot of flow. But if you're starting out, you don't have that luxury of having a lot of flow already. How else might you be able to get those routers to integrate you? There's a lot of things people have tried in the past, and it's important to learn the lesson from them. SDKs are great, and they can get you some integration over long periods of time. Begging and bribing, you can try if you have close relationships to a router or two. Maybe they will integrate you out of a relationship that you built with them. Maybe they invested in you, but it won't work with all of them. The only real way to get routers to integrate you is by already having a lot of flow. If you have a lot of flow, that means that solvers and routers are losing against their competition who have you already integrated, because they are bringing you flow. And that really puts on the pressure for them to integrate you. Now, this is all nice, but as we said, flow is reflexive. How are you going to get integrations if you need flow in the first place to get integrations? That doesn't really work. You're stuck in a bootstrap problem where integrators or routers don't care until you have a lot of flow, but you're never going to get the flow until you have a lot of integrators who care and already integrated you. So the only way out, and that's what we've been researching, and that's what we've been building for the last 2 years, is we needs to be a way for you to self-integrate into a tool that is already used by all the routers to discover liquidity. And it has to be almost no effort or zero effort for routers to add you, and all effort on your side. And only this way you can bootstrap yourself out of having no flow and getting the flow at the same time. Yeah, John, go ahead.
Hey, Marcus, this is great. Just a quick question. Can you just tell me again the difference between a router and a solver?
So in the context of this presentation, it doesn't really matter.
Okay.
So solvers are usually routers that are competing in auctions. Otherwise, technically, they're very, very similar or pretty much the same.
Okay, thanks, man.
Routers that compete in auctions are designated solvers in many cases.
Cool.
But good question. So the only way to solve this issue that you have a great DEX design and you want to bootstrap yourself into the flow that you deserve is by flipping the script and allowing hooks to self-integrate so that routers can discover them in a tool that they're already using. Now, this is by itself an interesting bootstrapping problem, which luckily it's looking very good. We've solved in the last 6 months, where enough routers and solvers are already using the tool so that they will continue to use it. And as soon as you self-integrate, you will immediately have all of that flow. And to illustrate what I meant earlier, this is really the way to shorten the time frame that you need to subsidize with something like an airdrop or points to the shortest possible time period until you have all the integrations. And then you don't need to subsidize anymore because you're on a level playing field with everyone else. You're on level playing field with Uniswap V2, with Curve, with Balancer. You have this access to the same amount of flow. This is really where you want to be as soon as possible. And this is what we built Tycho for. So it's an open source Rust library that solvers and routers increasingly use, and to a large extent already. So I put some numbers. At the moment, 20% of mainnet CowSwap flow is using Tycho. That's around 1.5 billion a month. And around 40% of base CowSwap flow is also using Tycho already. And not just CowSwap, there's also solvers who are using it for other auctions, such as UniX and 1inch Fusion. And what this really means is that with the one integration, you get access to all of those, or most of them, an increasing number, whereas before you would have to do n integrations to get that flow. And crucially, you don't depend on them and their engineering capacity. You can do it all yourself. That's the whole idea of Tycho, and I guess presented today why we built it this way, in order for you to be able to get the flow that your design deserves without having to do crazy BD work to get all those integrations. Yeah, and I'll hand it over to Alan here to show you how exactly that looks like and how Tycho is structured. So,
thank you, Marcus. Share the screen. Okay, I hope everybody can hear me, but it seems to be fine. So, yeah, I basically, what does a router or slash solver need to trade on a DEX? Well, first of all, they need to know what kind of pools are available by the protocol, and that's what we call pool metadata, or also protocol components. And it basically describes a pool mainly by its tokens. Also, we include the TVL values. And last but not least, any additional encoding data. Example for Uniswap, you need the pool key, which includes things like fees, etc., which are important to then actually execute the swap. This is one thing, and then solvers or routers use that to construct like a search space of potential routes to basically route through. Apart from this, they need, the most important thing that they need access to is the quote function. That means given your pool and the current state of the block of your pool, how much do I get for a certain amount, right? So like if I want to swap like 1000 USDC to USDT, how much USDT do I as a router expect to get? And also how much gas will it cost if I use that pool? So this is very important, and included in that quote function, I also need to know the domain of the input. And that's basically if the protocol or the pool has certain maximum or minimum amounts of a token. And outside those ranges, it might either not behave correctly or fail completely. So that is the quote function. And basically what routers do with this quote function is that they try to find a solution to a very hard optimization problem. And since these functions are black boxes, they have to execute them many thousands of times. And usually those executions have to happen within a couple of 100 milliseconds, because as UX for users who want to have, for example, a quote on the front end, might just be too slow or too laggy, and it feels bad. So yeah, basically the call function needs to be executed thousands, if not 10,000s of times within a couple of milliseconds. These are basically the requirements that routers are working with. And yeah, what makes, so you saw before the quote function needs the state of the current block, since like many times the price depends on what has happened last. So basically routers or Tyco needs to index that state. It means we need to like monitor the blockchain for any updates that affect the state, and then parse them and interpret them so they can be used by the quote function. Unfortunately, the Ethereum node RPC is not great for doing this because it wasn't really built for this kind of use case. Very often getting to the current actual state involves scanning the complete history of what happened previously. Like a famous example for this is Uniswap v3 or v4 ticks. Like to get the complete set of ticks, we basically, the easiest way to get this is to look at all the liquidity deposits and withdrawals that happened since the pool was created, and then kind of like aggregate that, and then you arrive at a current final state of what ticks are available and how much liquidity is on each tick. So yeah, that's one thing. Also, if you're unfamiliar with the protocol, so for example, if you're a hook developer and you're like, I don't know, you're like accessing liquidity from Aave or from any other external protocol, you're most likely unfamiliar with the internals of the protocol. So to properly index it, you would also need to spend some significant time getting familiar with the protocol and all its details. Another famous issue that comes into play during indexing is chain reorgs, and that ties back to the Ethereum RPC, where very often, if you use like a node provider in the background, they will load balance you to different nodes, which might be on different chain forks, especially if you're indexing very close to the current state. And if there is a reorg, like you will basically have two views of the same data that might be slightly different. And that famously leads to problems. And then there is some protocols that just lack logs for gas efficiency, or make it really hard to access some of the state using the traditional Ethereum RPC. So these are some challenges that usually come up during indexing, and then we think we have mostly solved with Tyco. So now, if you're developing a hook, how can you integrate with Tyco? There are basically well, before I come to the actual way of how to do that, we are currently still developing this, so a few things may still change. Things might be rather vague still, but we have a clear plan, and we will release docs as soon as the full feature is implemented. One important thing to mention now is that in the first iteration we'll only support what we call composable hooks, and composable hooks don't basically they just need on-chain data. And what that means concretely is if on the pool manager you rely on the hook data and you read from that and you need some kind of signature or anything like this, we might have to wait for one more iteration to properly support this. That's just an important distinction that I want to make clear from the start. Yeah, so basically Taiko supports two integration methods, the VM method, which summarizing is just very low effort for the integrators, but also is like rather slow CPU wise. That means routers can't do as many evaluations of your quote function. And then the native method, which is rather high effort for integrators, but offers best CPU performance for the routers. You basically have free choice which one you want to do, and the VM one is really low effort. Oops, sorry, things got mixed up here. Sorry. So let's go with the VM one first. One is really low effort. If you don't use any external liquidity, you basically don't have to do anything. We will basically simulate what your hook is doing on a local fork of the blockchain. So routers will actually, we supply them a fork with all the state necessary of all the contracts that your hook accesses. And we will simulate this and then return the before swap and after swap return values, and our Uniswap before implementation will then basically come up with the correct quote. So unless you use external liquidity, basically you're good to go. Like we really appreciate if you can send out your hook or like a test deployment so we can double check that everything works, since we're trying to cover as many edge cases as possible. But yeah, the most straightforward answer is you don't really have to do anything. If you use external liquidity, it means that the liquidity that you use is not in the pool manager and not managed via the traditional ticks of the pool. Then we basically need two things from you, and that's a contract method that returns the current input domain for the quote function and for each pool. And also we need an HTTP endpoint that basically gives us the return value, the TVL value for each of your pools. That's it for VM integrations. The native integrations are a bit more involved. They basically require you to write a complete indexing package. We use substreams for that mainly at the moment. That will kind of like return all of your hook state on each block. And then you have to implement a Rust trait that will have access to the state and basically implements before and or after swap. And that will then be integrated with the standard Uniswap before Rust package and should then provide like the best performance for routers. But since this is a bit more complex, we like really encourage you to get in touch with us before you start it, and then we can provide more clear guidance on how to do that, especially since the docs are not 100% out yet. Now, again, like a little summary of what is supported based on what kind of integration you provide, just to leave that very clear. So if your hook doesn't use swap permission, you don't have to do anything at all. You have the best performing implementation available. If your hook has swap permissions, it will work. It might be a bit slow, but most of the routers seem to be able to deal with that. If you use external liquidity, there will be very limited support for your pools that use your hook because we don't know the TVL value. And many solvers or routers use that kind of as a threshold to reduce the search space and to get rid of like a lot of noisy pools. Like there are many V2 pools that are basically dead, and those are filtered out, for example, by TVL. If you provide the TVL values and the quote domain, like this is basically taken care of, and then external liquidity pools work just as usual with the VM implementation. So really low effort. You just provide TVL values and the domain of the code function. And then if you implement things natively, of course, you get the best of everything, and it's the fastest support for all three cases here. And
you have a question?
yeah. Do we have?
Yeah,
Oh yeah.
yeah.
Please go ahead.
Yeah,
Okay.
this is a quick question. Let's say we are building a hook for synthetic assets. There are no strict sense of TVL or liquidity. Basically, between synthetic assets, it will be swapped based on Oracle price. Does it fall under the limited support category? Because there's no strict sense of liquidity. It will just be the hook will just burn and mint between different synthetic assets. Let's say like synthetic Tesla shares on chain or synthetic gold that tracks the asset price based on an oracle. And when you swap between these two, basically they do an exchange between the oracle price. So there's no strict sense of liquidity. So yep, will this kind of
Yeah.
hook be supported, or like it will need customized integration?
I have to ask you two questions to
Yeah.
give you a good answer.
Yeah.
Number one would be, where do you get the Oracle price from? Is that a push or a pull Oracle?
For right now, we'll be using a push-based Oracle, but in further iteration, probably we will use something like pipe, or we will use something like chainlink functions. But right now, we are using outright chainlink ready oracles. Yeah.
Okay. So if you, if you use like a pull-based one, you probably have to fall into the case that it is not fully supported yet, the one that I mentioned in the
Understood.
beginning.
Mhm.
If you read from like a Chainlink contract, the price of Tesla shares, for example, then it should
Right.
work fine, but probably falls under the external liquidity
Yep.
case.
Yeah.
And I don't know, like also the quote domain. I mean, like it depends. Like there must be some kind of notion of TVL, since like or is it just completely synthetic? This is a case like it probably falls under number 3 here, and we just need to
Yep.
kind of
Okay.
figure out what is a sensible value to emit here
Mhm.
for as for TVL. And for the quote domain, I'm not sure if you will have any issues there. I think. Well,
Okay. Okay.
how do you feel that?
Probably I'll look more into your docs when it's out. So we basically what we are building is basically like a MakerDAO plus synthetics compact, and we pack everything in a hook. So that will be a CDP based stablecoin, which will backed by yield bearing tokens. It will be the main exit liquidity because this stablecoin will be paired with USDC. But for all other synthetic assets, it will be paired with this CDP stablecoin that we created. So yeah, anything swapping between these pairs, let's say like synthetic gold, it will be paired with our stablecoin, and then it will be routed to USDC as exit liquidity. Yeah, and vice versa. Yeah, something like that.
Yeah.
In this,
So basically, you need to find a proxy for TVL, or just decide to not provide TVL.
but if you have a
In terms of
CDP,
like, yeah, go ahead,
if you have a
Marcus.
CDP, then at least the redeem, so the mint might not be limited by anything, but the redeem is limited by the collateral, the USDC deposited for all mints, right? So that is basically the limit.
Yeah, actually, we we structure it as in the sense that we have an anchor pool. We call the CDP pair. So our stablecoin that matches with USDC, we call it anchor pool. It's the stable swap math. We already implemented that. So for anything, all other synthetic assets will be paired with our CDP. So of course, the anchor pool will have liquidity. It will be externally managed by the hook itself because we uses a stable math. But
Yep.
yeah,
it sounds like it would make most sense to provide the TVL of that CDP collateral or that pool. If you provide that TVL, I think that would be most honestly representing the current TVL and be usable by others in that way.
Okay. Thanks. I will look more into the docs and we'll have arrange a talk with you guys. Thanks so.
Thanks.
Can I ask a little more on that?
Gotcha.
So first off, just a quick shout out. I've been following you guys for a while. It's good to see Mercer here and Tane, who I've chatted with before, and sort of great work you guys have been doing. Right now, I'm involved in the UHI 4 group, and there's a lot of talk about like just-in-time liquidity and providing that into pools. And I'm sort of working on a hook which will supply that. My thought to your point about sort of what is the liquidity there would be like right now we're evaluating flash loans, and so you could flash loans in. My question is typically the other way of doing it is basically have people, rather than depositing liquidity into a pool, just approve capital to be used by these just-in-time loans, right? Your thoughts as far as like flash loans versus actually drawing like liquidity providers to actually deposit liquidity into something which would be used for just-in-time provisioning versus sort of integrating also with, say, some yield-bearing protocols. Marcus, maybe that one's for you.
Okay. Well, I think this is really a design. You're asking from a design perspective or from what will be more attractive to routers?
So what I'm thinking right now is like I'm basically working on the solver and also that arbitrage that you've got in your Tycho X repo. So I've been looking at those two as well. So my specific question is flash loans like, and I was thinking, I was looking at Euler Finance and sort of also sort of like the V4 stuff. Have you seen where that's been like efficient, like where you can actually take a flash loan and repay that loan and have that as cost effective for the solver, if you like?
Okay. I mean, I'm going to answer from both perspectives. So from a perspective of, is it possible to integrate those protocols and those hooks into Tycho? Yes, we're actually working with some that you mentioned to integrate them into Tycho. And that logic is all hidden in the integration. And from the perspective of the router, from the perspective of the solver, it's just another quote request. And Tycho takes care of encoding that transaction. And well, you take care of the integration that Tycho knows what to encode. So it's definitely possible. That was what. And from the other side, is it from a solver's perspective a good idea to use a flash loan? Maybe that goes a little bit beyond this call, but in practice, what we've mostly seen is flash swaps. So instead of having a dedicated source for liquidity from a router's perspective, it's usually more gas efficient to loan from one of the pools that you're routing through. So, and that is possible with Uni V2 and V3 and V4.
Okay. And if you look in the chat there, Ludwig raised the good point about like you're going to have to on the other side of it, right? You have to do the arbitrage swap to get that worked out. So he's effectively saying that it's probably not an ideal solution.
You can't JIT. Like it depends if you're discussing like just-in-time liquidity into an AMM to provide liquidity. Then it's like pretty unfeasible most of the time to do a flash loan because once the swap has happened, your balances have changed to the point at which you no longer have the asset needed to repay the flash loan. And at the same time, to get the balance of the two assets in the first place, you have to do a swap. So you're basically paying to do a swap to then provide liquidity on someone else's swap, and then you end up with a disbalance in assets that forces you most likely to do another swap. So it ends up being very tricky. I'm sure like there might be some scenarios in which it works out, but very rare, I'd assume. But if it's more like solvers, like you're fetching liquidity to fulfill like an intent or something like that, that I don't know as much. I'm sure it could work, but it's probably not like capital effective or gas effective compared to someone with inventory.
Right. And so if we go down the intent route, and Marcus, you said that you've also been working with like the Uniswap X. I saw that you guys were one of the leading solvers for CowSwap for forever, right? As far as capital for that, how you basically like how does a solver get that capital upfront? Like obviously if you're competing against someone like Wintermute or anything like that, any thoughts on from the solver's perspective, how they attract liquidity?
So most solvers by number and by name have no liquidity. So that's the
And they're just
that's the
working at the
short
most
answer.
effective route. Okay.
Yeah, that's the short answer. So there is, and you can observe that in the order flow, there is a slight advantage to having your own liquidity, and like Wintermute wins more with their own quotes than with the quotes that they provide to solvers. But by and large, solvers have very wide access to makers' liquidity through quoting services like Bebop or Hashflow or direct integration. And yeah, so far we've seen very few teams who focus on both algorithm and liquidity. It's either liquidity or algorithm.
Okay.
Generally.
Okay. So if you're working more as a solver, focusing on algorithm, integrating with liquidity providers like Bebop or Hashflow is something which a lot of the guys do.
Yes.
All right. Thank you. And then just one follow-up question. With the Uniswap X side of things, I've been following like the development of the compact and this arbiter for these cross-chain swaps. Have you, when I ping them, like it sounds like they haven't deployed those, they haven't worked on that as yet, like it's not out in production. Are you using those contracts and sort of using those to hold any funds or integrating with those contracts at all?
So when you want to be a filler on UniX, you need to use their contracts for filling.
Right.
If that was what you mean. And we didn't have any liquidity in those contracts, no.
No, what I'm specifically talking about, and I'll just paste the link in the chat. Have you seen this repo at all?
Yes, of course, yes, but no, we haven't worked with that.
Okay, cool. Thanks, man. I'll hand it back. Appreciate it.
Yeah, thanks for the questions.
Great. So like the last part is just like a quick overview on how Tycho works for those interested. So basically Tycho can be split into like roughly 3 parts. It's the indexer, which we run as a service, and anybody can get access to if they contact us. And the indexer basically receives data from the blockchain. We use Substreams as our main data provider for that. Then interprets the data, saves it to the database, and handles informing any connected clients about any updates. Then on the client side, we have the Tycho client, which is basically used to connect to the indexer. And the Tycho client is then used to feed data to Tycho simulation, which is the library that contains all the quote functions and a few more things like price functions, which can be numerically estimated from the quote function in case they're not directly provided. But also we offer Tycho execution, which allows routers to take any swap or quote that they receive from Tycho simulation and actually execute that on chain. And then we have to actually router a solver application which uses those libraries to, in the end, form a transaction and send that back to the blockchain. Happy to go into any more details here if there are any concrete questions.
Yeah, just with that, Alan, when I look at indexer there, if I look in the total Tyco protocol SDK, under the substream folders, you've got all the different sort of implementations for the various. Can you just talk a little bit how the SDK integrates in this picture?
Yeah, so the SDK is basically here on the bottom. It's on the substreams. So we compile these packages to WASM, and they get sent to the substream service, and they execute them, and then basically send us only the process data. And it's very convenient for us because they basically help us to parallel process like big historical ranges of blocks very quickly. And it's actually quite nice how they do it. They use a lot of big data ETL kind of processes for that, and provide very nice ways to aggregate data. So actually thinking like a big range of historical data is quite big. And actually the current bottleneck, if we have to resync, is our Postgres database and not actually the speed at which we get access to the data.
Wow.
Sorry, good.
So quick question. That's really cool. So in terms of like integrating like our hook or our protocol, could you basically have like create your own module like based on the substream spec or whatever, send it off, and then you receive that extra data? And if so, does that like indexing module, can that indexing module access external data sources that aren't like purely the like Ethereum like DB? So you could like basically overlap your external data source from some API with the substream that reads directly from like the ETB, and then directly give you your like cleaned up data to you guys.
Yeah, that would be great, but unfortunately, that's exactly what is not possible. So substreams really can only access ETHDB data, and they don't allow it to do any other external networking or whatsoever in the WASM. So yeah, unfortunately, that's the current limitation, and we're like looking into how to ideally get data from like an external source into Tyco. But yeah, unfortunately, the short answer to this question is no. But like the other part that you said is completely correct. Like if your hook was only using basically ETH blockchain data, you basically develop a small package that extracts exactly that data, and we inject that into our current v4 package, and then your hook state is basically emitted as part of our v4 state.
So interesting. Okay. So, and are you like envisioning creating like an additional like layer on top of the substreams? So like a middle point between the substream and the indexer, where we can still return like the consistent format that you expect with the layered in data? Is that the
Yes,
idea?
so we probably will provide like a trait that can be implemented in Tyco Indexer to basically pull additional data. Actually, not quite sure yet because we haven't seen enough example if this is going to be in the indexer or in the client. But somewhere on this axis, like either here or here, there will be the option to pull data from like non-blockchain sources or other blockchains and actually combine that. So once you want to actually quote, you have all the data that you actually need.
Awesome. Very.
Elaine, a question about the simulation and native versus EVM. I sort of had a bit of a look through the code base, but I'm still a little confused by there's some Python libraries, and I know that like you replicated some of the math there, which is used. Can you just talk a little bit how that works?
Yeah, so I understand the Python library is confusing. Like the Python library actually is just bindings to the Rust library.
Okay.
And we haven't really had enough manpower to maintain those properly. So actually today we decided that we probably like remove it for now and might come back later once we have enough time to properly maintain that. But yeah, in short, like the Python package, it should be somewhat functional, but it's not maintained at the moment. The Sorry, what was the other part of your question?
So basically, like native versus EVM, like you said, like the native was a
All
heavier
right.
lift, but was a lot quicker. Can you just
Right.
talk a little bit about how native works?
Yes, for sure. So the native implementation, like you basically have to translate your Solidity or Viper or EVM bytecode logic into Rust code, and that compiles then on the router's machine into native machine code. So it's very efficient and very quick to basically come up with a quote, since it runs in the native CPU of the router. As for like the VM integrations, what happens is that we use REVM to like spawn like a local VM on the router's machine and just interpret your like Solidity, your EVM bytecode of the hook basically to come up with a quote. And that unfortunately is just like slower since it's interpreted code versus like natively compiled code.
Okay, that makes sense. Appreciate it.
Awesome.
Oh, one other question. Speaking about oracles before, I saw on Pith Network that they, as far as data providers, it had you guys listed as a data provider. On the Pith Network, is that true? What's going on there?
Marcus, you wanna take this one?
Sure, yeah. We experimented for a bit when we were still running our server, which we are not. I mean, you still might see our server. It's basically our integration test for Tycho, but we're really not maintaining our algorithm there. And yes, I think as a server and as a router who has visibility of on-chain data, you're a very good a provider of data also for oracles. And we experimented that for a few weeks, but didn't continue with that service. That was a bit a while back.
Okay, thanks, man.
I have a last question in terms of the execution. Sorry for the question spam.
No worries.
When you're executing, so you basically like you're indexing all of these events, and then you have the state with rhythm, as you mentioned, and then you're doing like the state execution. With the indexing, is it possible to do like a state override of a virtual event? Effectively, like you're emitting a fake event so that when they simulate, they're effectively simulating on like overrided state, which isn't like real chain state, because it will be chain state. Does that make sense?
Yes, I understand.
And
Since
I
I know
probably
more
know
or less
why
why
you're
you're
asking
asking
this.
this.
Yeah.
Yes, it's possible, is the short answer, but it's not really. So there is a public interface to do this, but it's not really meant for that case. So I think it's possible, yes, but I have to double check. So I think the answer is 90% yes. There's basically you can transition a pool with a delta message, which is quite straightforward to craft, and then you get like a new copy of that pool. So basically yes, I think it should be possible.
You expect this to be live for like V4 hooks?
Sorry.
Like when do you expect all of this stuff to be ready for like V4 hook integrations?
So the first situation that this won't include like the hook data times support. I think earliest in like 6 weeks, 6 to 8 weeks.
And if we're working on a hook and wanting to sort of like help in that process, I assume I'll just reach out on Telegram to see if we can add some value there.
Sorry guys, I think my connection just dropped. So John, I didn't get the full question.
No, it's just something I'm interested in. So I'm working on a hook right now. So as it moves forward, I'll probably look into the architecture a little bit more, and I'll reach out on Telegram to see if like I can help with that at all. So
Yeah, that would be great. Yeah, and if anyone, if you could help, like if you're developing a hook, please get in touch with us on Taiko.build. We would love to check if your hook works just out of the box with what we have planned so far. So yeah, please feel free to reach out on Telegram.
Cool. I really appreciate you guys. Propeller Heads has been around for a while, and I finally got a chance to really hear more about you guys and this infrastructure that really brings all of us together, which is kind of what crypto is about. So I really appreciate you guys coming out and showing love to the Atrium's crew.
Thanks, glad to be here.
Yeah, thanks. And thanks for the great questions, guys.
Yeah, amazing infrastructure you built out here. It's really interesting to see how you went from like being a solver yourselves to actually build out the whole thing to help everyone else out. It's been fantastic. So
Thanks.
Great, thank you.
Thanks, guys. Thank you.
Thanks a lot, guys. This is great.
Thanks,
Nice to
guys.
see you.